Right. Let's talk about your uh, final project a little bit. So in about 2 weeks, we would like you to have a research question identified, data set identified, and mainly a group of people you will work with. And then there is some rough methodology, so maybe you would at least have a little bit of idea what's about to happen. So important thing is that you need to ask a question that you will try to answer. Sometimes it can be that you find the data and from the data you figure out the question, but you can start with either thing. But it's important that we would like to have a question such that you have some observable facts and you derive from it something that is not known yet, or something that is from future, would be obtainable as a knowledge in future. Okay? So what are some good rules of when you are trying to find answer? You can try to ask, what do I expect to happen? If you have something like that, that may be a good question. Is what you are asking, can you answer that question in future or in principle? Right? Does it have an answer? And if the answer is not obvious, if the answer is obvious, it's not a good project. Right? Sometimes a good thing is, can you bet on the answer? Okay? So the answer can have several different options, and if you can bet on it, then maybe it was a good question. Right? On questions that you cannot bet, probably those are not the good questions that you should be asking. Right? We'll see a few questions that are good and that are not great. For our particular project, the word future is kind of maybe tricky, because if you have a time component in your data, then we are a little bit out of luck. Simply because one needs to do some time series, and for time series we don't have enough time in this class. So you should be thinking about future, but not in a future that you have a date set. So here is example. You may want to create cookies, and you want to make cookies that are good, right? So you look at different types of cookies, what are the ingredients, you measure how many people like each type of cookies, and then you can try to say, what if I mix these things together that are not in any of the cookies that are already tested, how popular it will be. Right? That is a thing that you can observe in the future, how popular such cookie would be if you make the cookie, right? But there is no time component to it, like something like tomorrow or next day. For example, stock prediction is bad in this idea, because you have what will be the price of a stock tomorrow based on the data that we saw today. That's something that you should not be doing in your project. So here are examples or questions that are bad, and then maybe we will try to come up with versions of these questions that are better. Right? So here is first one. How much did my neighbor pay for their house? Well, it's maybe interesting question. Maybe you want to know how much was the house worth for your neighbor, but it's fairly easy to find. You go on Zillow, and on Zillow there is the number, right? Okay, it should be in some county records, if more exactly, but yeah. Anyway, so it's a question that you can easily answer, and nobody will be willing to bet on it, right? Because everybody can figure out what the number is. Alternative question could be, if my neighbor would want to sell their house now, what would be the selling price eventually? Right? It's not obvious what the answer is. Right? You could bet on it, how much money the neighbor would get when they would try to sell the house, and in principle it's possible to find out if they sell the house, if they try to sell the house, right? So then it's a more interesting question, because there is some unknown part, right? Here's another question: which candy is the most popular? But it's not maybe a obvious answer what's the most popular candy. You could try to have a study where you have a lot of different candies, let people taste the candies, and see what they will say, which of them is most popular. Right? Better version of the question is, you are running a company that is making candies and you want to make a new candy. If I tell you the ingredients of a candy, can you predict how popular the candy would be? Right? It's a little bit like the cookies question. And what you could do is you can try to create data by looking at the current candy, what are the ingredients, you measure the popularity by doing some survey, and then if somebody gives you a bunch of ingredients, you may be able to create a model that will predict the popularity of the new candy. Right? Or here's a question, how many members are on an NBA team? It's a question that may be interesting for some people, but it's fairly easy to find out. Similar like the price of the house that my neighbor paid. It's not a surprise thing. Nobody will be willing to bet. You can try to have some other question, like, if I give you a shoe size of an NBA player, can you guess what their height is? Right? Maybe you can try to make a model that will try to say, oh, the shoe sizes will correspond maybe to height a little bit, and then you can have a guess. Or another question: does my girlfriend or boyfriend or mom or dad love me? Well, it's a tricky question, because how do you answer? Yes, no, or is it a numerical answer? Is there some like scale of how much love there is? Right? Maybe a better question is something like, what's the expected number of dates during the first month? Right? Or what is the expected number of dollars spent on gifts? If you have some track record, you can try to guess how much people spend money, or how many dates they are willing to go on. Here is our iris dataset, favorite one, right? And it has the sepal length, sepal width, petal length, petal width, and species. And is what questions can you ask if you have this data? Right? Pretty much what you can do is you can look at any of the columns you have. There are 5 columns, and you can have a question: can you predict the value in particular column if you know the remaining columns? Right? So, for example, you can ask, can you predict sepal length if you know sepal width, petal length, petal width, and species. Or maybe more interesting one is if you know the measurements, can you predict what species it is? Right? That one could say people may be interested in. I give you measurements of the plant that is growing in my garden, and you tell me what species it is. Is a question: can you ask which species is most popular? Right? And well, you can ask that question, but not with this data, because this data doesn't indicate in any way which of the species is most popular. That's the first thing. And the second thing, it is not a prediction in a way, right? Here you have 3 species, and one of them would be most popular if you have some popularity contest, but there is no prediction. It's you sort through the data, and that's it. There is no betting in a way, right? So here is in general, if you have data, you can try to ask to predict value of one column from the remaining ones. So if you have question that you want to ask, you need to find data where the answer to your question is one of the columns, and the remaining columns are other properties that are somewhat related, hopefully somehow as correlated with the answer you are looking at. Right? So if you have a question, you can do 2 things. How to get question. You can have some topic, and you try to find data set about the topic, and when you have a data set, you try to figure out what the question could be. Or you can try to start with a question and then find a data set that provides answers to those questions, to the question you have, and see if it has enough other columns such that the answer may be correlated to several of the columns and can be guessed from the remaining columns. Right? I hope it made a little bit of sense what I tried to say. So, how do you find the topic? A good thing is to do a topic that you like. Right? Maybe it will make the project more fun or easier to motivate yourself. People have different things they like. Right? Some people like water skiing. I think Iowa State has a water skiing club, a nice water skiing facility just south of Ames. Or you can have as your hobby chess or photography, online gaming, sport analytics. Those are some things that students set in the past in the class. Right? You can have as hobby UFOs, whatever makes you happy. Where do you find data? Great question. There is the website kaggle.com, and you can search for data there. If you write a keyword, you may get a bunch of different data sets. There's World Bank, United Nations census data if you are interested in those. A little word of warning: if you try to go on websites where users can upload their own data, sometimes the data is not very good. As is, the column names look great. It looks like it will be very good, very interesting thing. The description also looks very interesting. And then when you look at the data itself, it's just random generated numbers. Nothing that has anything to do with the real world. Right? So be careful. Just because you found that somebody uploaded data on Kaggle that look like data that you are looking for, it doesn't mean they will actually work for what you want. Alright? More notes about the final project. Okay? you would like you to be in groups, 2 to 4 people per project, and you need to now at the first steps identify the research question and data set. It goes hand in hand, right? And you would like you to figure out if you are trying to find some linear regression, which means you are trying to predict a number, or if you are trying to do some classification, which means that you are trying to predict a category, right? For example, if you have 3 or 4 different options, then that would be classification. If the number that if you are looking at something that is a number, maybe from 10 to 100, then maybe you have a linear regression. Okay? If you have questions or you are puzzled by things, you're always welcome to stop at any of the office hours for some extra support. Right, your project. How does the life of project looks like? Is this data science process that we'll try to go through. So there is ask question. I have a maybe here, because maybe you first get the data and then you ask question. Right, so you get data, you look at what is in the data, explore the data, then you figure out if you can answer your question from the data. Right? Is there a column, or can you create some kind of derived column that will answer the question you are trying to figure out? Okay? And then there is make and test the model. That is something that we still will do, and then you present your findings. Right? So now we would like you to do first few of the bullet points, and this is how the life of data science project generally looks like. Ask question, get data, explore data, model data, and present results. You can see that on the right there are always the arrows going back up, which means that you can ask question, get data, and then you figure out, I didn't get the data that are good, I have to get them again, or the question that I ask is not good, I have to go change the question. So you can move around. Maybe you will find out that the model is bad, you have to redo the question. It sometimes happens. Here is a more detailed version of what you would like you to do eventually. So if you have your questions already, you get the data, explore data, see if it's possible to answer, make model and test, and then present finding. Right. Getting data come in many forms. Typically, if you get data from Kaggle, you will get some CSV file and life will be easy. Okay? But sometimes data are found in some database, or you can try to do some web scraping. If you want to do something fancy, you can try to combine data from few different sources. Right? So if you want, you can spend a lot of entertainment on it. If you don't wish, you don't have to. And there is the exploratory data analysis. What one does is you look at the data, you do something like seaborne pair plot, see if there are some relations between data a little bit, see if the data makes any sense. Right? Maybe the data that you get was randomly generated and you didn't see it, so now you should see that the data is completely randomly generated. You should check if whatever are in the data have reasonable values, right? So you try to plot the data if you can and see if whatever you have is at least a little bit plausible to what you would expect. Data cleaning is the main part of life of data scientists, right? You have to find if you have incomplete entries, what you do, if there are some big outliers, if you want to remove the outliers. Sometimes there are errors in data because just people didn't correctly enter the data, right? So you should look through the data and be a little careful. You may be lucky, and sometimes the data on Kaggle are already very clean, sometimes not, and then, well, usually people just do drop NA and that's it. Sometimes you'll have to do some rescaling of data. Some of the models need data that are nicely scaled. Sometimes you don't have to, right? So it's a thing that is good to be aware of. Then before we make a model, we will split the data into training data that will be used to train the model, and then part of the data will be put aside as a set for testing to see if the model is any good. We will do this again more carefully later. This is just a little preview what will happen. Then one tries to build model based on the training data. Right? It will be fairly easy because there is a library of many models, and what you do is you say, here is some data, fit it into the model, and life will be great. All we have to do is go through the models, so we at least a little bit know what each model does. Okay. When you have the model, you'll test the model, see if it performs on the testing data reasonably. Then maybe you will be able to rely on the model, and you say, we created a great model. And finally, we would like you to do some nice presentation where you should say what you are doing and how your model performed. You can do some pictures, right? Life is great if there are pictures. Right, and here is a little bit of matching of the two diagrams. You have the ask question is missing in the left, in the right there is one, and then the get, explore, and model is in a little bit more details on the left. Alright, so please take a look at the final project. Make groups. There are a few ways how you can do it. We would like you to indicate your groups on Google Sheet, so you can see what are the other groups and what are the other students in other groups, and then also indicate it in Canvas, because then you need to submit some assignment, and if it will be correctly indicated in Canvas, only one person per group needs to submit.